converting Excel into CSV is still the most reliable way because the Excel file often contain non-spreadsheet information, right? So in those cases, it is tricky how to handle those non-spreadsheet data to begin with. So convert them into CSV is really one of the most reliable way. And all you need to make sure the Excel spreadsheet has a clean data there for R to read. So, and the example we are going to use, let's see. Input, now to be the input output plot RMD file. Oh, have I haven't shared my screen, have I? Sorry. After the bootcamp, I will editing the video and then release it. Actually, many of the video are already online. For example, the basic R coding video, I believe, is already online. Molar solution, that one online. But I will edit this video and also post the link there. So for this input output exercise, that will be the input output plot RMD file. So here we are reading E's growth curve data. It's very simple, just two columns, hours, and then the amount, the E, relative amount the E's are growing. With the amount, the dollar sign with the amount, with the y-axis, and hours are the horizontal one. So, and we can actually do a better plot by removing the dollar sign, but using just the data and remove the dollar sign to make the yes, when people read it, that dollar sign really doesn't mean anything. So we can also add a title. This will be Carson growth curve, and we can also change the type of the plotting. The B is actually quite intuitive. B means a circle plus a line. So that's the type of a B plot. So by default, it's a scatter plot. So when we do not specify the type of the plot, it's a scatter plot. When we change the type, it equal B, and then it is this circle line plot. And so in basic R, when we plot multiple data, it's actually relatively easier than ggplot. So in the basic R, when we plot, in this case, we have the Carson 2. Carson 2 will have what? 2 columns of data we want to plot. And in this case, we can plot the first one, and then we can just add the second one as another line, and then we have 2 plots. So this is quite straightforward in basic R for multiple multi-plot. And we can add more color to make it more clear. So, and here in this revised plot, I'm going to say both the label will be amount, the how much growth the E has been, and then the Y label is hours. Change that I changed the line type, make sure the type is line. And we can also change the line type, L type. 2, I believe is a dashed line, is it? Yes, that's a dashed line. A man for growth, change the title to growth comparison and make the color is blue. Is the color blue? Yeah, bluish, blue. That's the line. So this is for the first line. And the second line, I'm going to say make the color is red and the line width is 5, or that's a very thick red line. So this is well, we draw a very thick red line here. So that's for the second one. We can also make a legends there. So I'm going to put legends at the bottom right. The first one, or maybe that's wild type. Second one is the mutant. We actually, this is just making things up. I don't even know what that two column refer to. So the first one we say that's a wild type. Second one the mutant. And the first one, because we plotted the blue, so we are going to also put the legends of the blue. And the red, that's the for the mutant. LWD, the line width, again, is 1 and 5. LTY, the line type. 2 is dashed line, 1 is a solid line. So unfortunately, all those numbers, this you don't have to remember, you just experiment it, right? So if I don't remember that, we can switch 1 or 2, see what happens. So this is actually interesting. The dashed line is it doesn't even have enough space to show. If I say 1, okay, now it's yeah. So now we just switch the line type. So, yes, I can also change that into 1 to make it more consistent. Well, then this is very bad legend because the blue and the red line type also switch. So now we put it back. So that should be 2 and 1 is actually not appropriate. So, okay. So and this will be dashed blue line of a wild type, solid red line for mutant. So, in fact, there's a lot of information you can make. You can actually intentionally put the legend at a different place, and instead of bottom right, you can even specify the position. Like in this case, I'm a specify position at the 12 and 250. See how that looks. Let's see how that looks like. Oh yeah, it's actually now it actually looks a little better than just bottom right, isn't it? So, but oh, I didn't specify that line type. If I say line type equals C 2 and 1, then also added a dashed line there. So, yeah. So now it really depends on your own preference. I think this one is actually better than the other one. Well, it also depends on advisor's choice. Yeah. Okay, this is just a simple R plot for multiple. This is for overlay. So first plot the first variable, and then use the lines to add the second variable. Now you may think about what if the two numbers are of different scale, and then you need to change the scale of the variable. The scale will be if I change the scale, y limit. Let's see, what's that? From 0 to 300, 400, 500, 600, 700. Let's change now to 1,000. How about that? From minus 100 to 1,000. Yeah. So now if you know the scale, you have to manually change it. So uh, there may be ways to automatically rescale it based on the maximum range, but I don't know how to do that. Yeah. There must be another function, something. Well, what I often do just manually change the scale. So. Okay, so I think we mentioned this. You can actually see the PCH, how many symbols you can use. I don't think people actually use all those symbols. It's probably 1 to 25 is the most recent, most commonly used one. So, um, uh, so let's see. This is another plot of a different data set. This is the sunflower seed data. Sunflower seed data. And if you actually pick the sunflower seed, you know there are some stripe on the sunflower seeds. Apparently, some people have counted how many stripes on those seeds and binned them. So what this means, and on those seeds, if it's solid or solid white, solid black, that there's 0 stripe. And here we have 5 seeds. If there's only 1 stripe, we have 3, and 2 stripes, we have 25. And it looks like 6 stripe is the most frequent one. 4 and 6. So basically, this is the data I got. I don't even remember where I got this data. Well, you can actually have a few hundred sunflower seeds, just count the stripe yourself, you will get the new data set. So, and then if we plot this one out, this is actually a type B plot. So the X label is just the number of sunflower seeds. The vertical axis is how many stripes they have. This is basically a histogram, but we are looking at it horizontally. So. And we can, so this is very basic plot. It's probably good for students to write a lab report. Nowadays, we don't use this for publication anymore. We all switch to the ggplot for publication quality plot. But this actually is much more easy to use if you want to just explore the data set. And perhaps one of the most important thing you want to learn for any data science, how to output your result. So in R, still the most reliable way is still to output into a CSV file. This is especially useful when you work on I often have to do distributed coding. I run code at the high performance computing clusters. So if you want to output your file in Excel, very often you need to add extra package, and you may or may not be able to add those packages when you are running the batch code on a high performance computing cluster. So using the basic R, you make sure you can output that in a CSV file. So this is CSV file is still the most reliable way to output your result. So, or if not CSV file, is something called a tag delimited file. CSV is a comma separated, and apparently in data science, especially in biology, we often use tab. Just the tab command on your computer, there's a tab, and use that as a separated file. So let's see, in this example, we have X is from 1 to 30, and Y is just a square power of X. And then we can write X and Y as CSV file. But we can also combine them. So if I do that, X It's just a list of number. Y is also a list of number. But writing them separately isn't very informative. So if I do that, you will see x.csv probably at the directory. Actually, if you go to the file, three input there. So x.csv is not there. So view file. Yeah, so that's the x. It's basically a list of number there. So, but we also want to come instead of 2019, change that to 2021. 2019 is May 30th, the workshop. 2021 is 08. Today is 18. Okay, so let's change that to XY 2021 051A. So what I'm doing here is cbind. Remember the cbind? Cbind is a base function at my bottom right window. That's the help page information of cbind. Is cbind I don't see it. Well, C is for column, R is for row. This is like not very good help information, right? Because cbind it says combine object by rows or column, but the column is the first, row is next. So it's combined by columns and rows. That's more appropriate. Cbind actually is, yeah, this I think someone need to update this the help information. Otherwise, really confusing. So cbind is for column, rbind is for row, but somehow the order is not the same. So cbind first, rbind second, but the title says row first, column second. So yeah, well, R is an open source package, so for some reason nobody bothered to change this. So, okay. Output is the cbind x and y. So if we do that, and let's look at output. X and Y are two columns. So, and then we can just so that's our new object output. That output, if you look at it, is actually not a data frame. It's just a matrix because they are all numbers. But we can still output that matrix directly as a CSV file. So if I run that code, and now if you go to the file, there, yeah, XY 2021-0518. And we can actually view that file in RStudio as well. So it actually is a CSV file, 11243946. That's the output of CSV file. And let's see if I say write dot. Once you see write.cf, well, because I just uploaded APE, so there's actually a lot of, you can write CSV, write.table. This is another function. Write.table means it's not just CSV file. If we look at it write.table, this is actually is more versatile than write CSV, which means you can actually specify a lot of features. So if I don't write this in CSV, I can say write.table output, give it a different name, xy 2021-0518.tab. Separate. I'm going to this is by default the separator value is space. But what I'm going to use the tab separate. Separate is a tab, which is the backslash key for the tab. And then I'm also going to say row.names equal false. We don't really need a row name here. Okay, if I run this and then go click on the file again. There, XY 2021 OI1A. I typed the extra two here. Oh, never mind. So let's look at this file. You'll see there. Instead of the previous one is the comma separated. Now this is tab separated. So it's actually more easy to see this on the terminal. So if I say, if we look at the tab information there, so it is separated by a tab. And this is almost like when you write a Word document, the first sentence you tab it. So, but otherwise, if you look at the CSV file, it's comma separated. So this comma separated is easy for a computer to read, but it's hard for human to read. Right? So 1, 1, 4, 16, 9, 81. But if there are many more numbers, this will become really hard to read. But tab separate, especially in bioinformatics, when you align the sequences or have different column or different feature, and a tab separate can be very easily to check visually. Okay, so this is the output of CSV or a tab file. So that's again a plot. Yeah. So this is that. I think this is it. It's a very simple exercise, but it's probably one of the very important feature you have to use. So I cannot find the table and the files. If that's the case, you need to change the directory. So if you click the file, so in my case, if you are in a wrong directory, if you click file, you have to go to different directory. So it goes up, and then if I go all the way up there, so this is really a lot. That's because my GitHub has really a lot. You see now home GitHub, that's actually not a good idea. Can I go down? Yeah, my GitHub directory has too many things, so it's I can't even find it the back. Okay, now open it. Okay, good. Oh, it's actually a connect to browser very well. So now you want to make sure you are in the right directory. So we are now in unit 3. Click input output, and then hopefully you will see this. And or you can just use your own browser. Open up the browser to see this. Yeah.